Hi everybody, it's Mrs. Peachy from WCA Physics, and today I'm going to make a tutorial on how to do relative velocity problems. We're going to go through problem 3 and 4 because those are both using vector addition. Okay, so I'm going to angle this down here at my notebook and give you the full screen view here. Okay, problem 3 says a ferry is crossing a river. If the ferry is headed due north with a speed of 2.5 meters per second relative to the water, and the river's velocity is 3.0 meters per second to the east, what is the boat's relative velocity to the earth? So this is a vector problem. So I'm going to just set up some coordinates here. I know that the river is moving 3.0 meters per second to the east. I also know that the ferry is going 2.5 meters per second to the north. And you might be tempted to put your arrow here for the northern direction, but tip to tail, remember, is what we like to do. Then we need to draw our resultant vector right there. And we need to know what this is. This will be the velocity of the ferry. As you can see, we have a beautiful right triangle. So we can go ahead and use the Pythagorean theorem. 3.0 squared plus 2.5 squared equals v squared. And when you do the math for this one, you'll end up with a velocity of 3.9 meters per second. Now you can figure out this angle by just using some trig. I like to stick with the numbers we were given, the 2.5 and the 3. So opposite over adjacent is tangent. So I'm going to take the inverse tangent of 2.5 over 3.0. And the angle is approximately 40 degrees. Okay? So I can say that my ferry is moving 3.9 meters per second at an angle of 40 degrees north of east. Okay, pretty simple. They already gave us the x and y coordinates for that one. Problem 4 is a bit trickier. It says a pet store supply truck moves at 25 meters per second north along a highway. Inside, a dog moves at 1.75 meters per second at an angle of 30 degrees east of north. What is the velocity of the dog relative to the road? So we know that the truck is moving at 25 meters per second north. We also know that the dog is moving with a velocity of 1.75 meters per second and at an angle of 35 degrees. 35 degrees east of north. So this is east of north. So we need to figure out the x and y coordinates of this dog. So I'm going to go ahead and just draw my right there. Probably should have put my arrow the other way. Notice we have the 35 here, so that means that this angle here is also 35 degrees. And now we can use just a little bit of trig to come up with the x and y coordinates here. So, opposite over hypotenuse, sine of 35 equals 1.75 over x. Cosine 35 equals 1.75 over x. good gravy. This should be x over 1.75, and this should be y over 1.75. My bad. All right, so we have 1.75 sine 35 and 1.75 cosine 35. So let's do that on the little calculator here. Sine of 35 times 1.75 gives us pretty much just 1. Okay? And cosine 35 plus, or excuse me, times 1.75 is 1.43. All right, so now this is going to give us our x and our y coordinates. So now you have to think of relative velocity here. The velocity of the dog is his velocity plus the velocity of the truck. So his velocity, you have to add to the truck's velocity. Okay, so this is just his velocity in the x direction, just so we're clear. So we're going to add the 1.43 to 25, which is 26.43. So that's our x. Okay. And then that's our y. Goodness. And our x was just 1, right? So our x was 1, tip to tail. And we need to figure out this hypotenuse. That'll give us the dog's final velocity. Okay, and we could put this in terms of Cartesian coordinates so you can kind of see what we're looking at here. So he's moving in this direction. Let's use let's just use the Pythagorean theorem. 1 squared plus 26.43 squared equals h squared. Solve for h squared gives us, well, 26.4. Pretty much, the same. Now we need the angle. And what I want you to notice here is that this angle here is the same as this angle here. So I'm actually going to look for this angle. That's what we did initially, and we kind of have to stick with that. So that's the angle I want. So, let's see. Opposite, we could do opposite over adjacent, 26.43. So 1 divided by 26.43, and do the inverse tangent of that. And inverse tangent gives us an angle of 2.17. Remember, that's this angle. So we might say 2.17 degrees east of north. Okay, east of north. Or, you could subtract that from 90 and say 87.8 degrees north of east. They mean the same thing, so. Okay. Hopefully that helped out somewhat anyway. If you have any questions or concerns, feel free to give me a phone call. My extension is 2204, or you can send me a webmail message. Have a great day, physics students.